Hello, everyone. My name is Alisha Wellington. I'm a senior at Penn State University studying meteorology and atmospheric science. Today I'll be talking to you guys a bit about a hurricane that we studied, Hurricane Fred, and we pretty much improved the forecast using Meteostat 10 alongside infrared radios. So this is just a short introduction. Cape Verde is an island nation composed of 10 small islands in the Atlantic, and so it's right off west of West Africa, and so it's a really small nation of 550,000 residents. And so what made this hurricane significant was it was the first hurricane to occur in the Earth in 120 years. So, okay, so just a short overview. Specifically, since Cape Verde is such a small island nation, it's pretty much in the Eastern Atlantic as well as Cape Verde itself is really a data void region. So this provides some challenges for meteorologists to be able to understand the ongoing state of the atmosphere. And so the main objective of our project is to improve the forecast of Hurricane Fred using data assimilation. So data assimilation is a statistical technique that combines forecasts and observations in order to create some improved initial conditions. It's just a little insight regarding our data set methodology. So again, our major data set was the Meteostat 10 satellite observations. That's how we got our gradiences. We also used the ECMWF reanalysis data to get some idea of the synoptic information. We also used the National Hurricane Center satellite observations as well, of course, the simulation from weather research forecast work for sure. And just to add on just a little bit more, specifically our data assimilation system is known as the Penn State or NKF system. And so the horizontal resolution on the bottom domain is 15 kilometers, while the inner domain is 3 kilometers. And we ran this simulation from the 29th of August to the 1st of September, which is pretty much the duration of this category 1 storm. And so just for you guys to get a little bit of an idea of pretty much the start of this storm. So it began in the African Easterly Jet. First as just a small tropical disturbance on the 29th of August. And pretty much the low pressure you can see on the right side, it intensified and deepened toward got delta 108 millibars. And then it continued to intensify when we had some more warm water, and then we saw a tropical depression on the 30th. And then it officially became a category 1 storm. And so the first part of our project really focuses on analyzing the poor forecast, I should say. And so this is simply just comparing the WRF model with the National Hurricane Center's official observations. So here, if you look at the best track, the National Hurricane Center's observations are in red while the WRF forecast is in blue. And here you can see there were some pretty notable discrepancies between the forecasts. The National Hurricane Center track of this conflicting observation started a bit north of the WRF model. So you can see there was some conflicting conflict with the forecast and pretty much where it was supposed to, where it was expected to be, specifically on the 31st, which was the most vital day of the hurricane. And then when we look at the intensity, first we will take a look at the pressures. Here again, you can see there's a really notable discrepancy in the WRF forecast and the National Hurricane Center's observations. There was as much as a 10 millibar difference. And the issue with this is we need to understand how deep that low pressure is getting in order to quantify how intense a hurricane would be. And then moving on to the maximum wind, also essential with being able to categorize a hurricane. So here there was as large as a 27 knot difference between the maximum wind reported between the National Hurricane Center and the WRF model. And so basically the WRF model highly underestimated this storm, and it did it pretty much, if we went based off that, it wouldn't be classified as a hurricane itself. And lastly, again, just comparing the National Hurricane Center, our WRF model, you can see that the WRF model did not capture the high cloud tops associated with this hurricane, again, which is problematic with being able to understand how intense it's going to be. It also did not fully quantify the magnitude of this storm, and these are over the same latitude range, so you can kind of see the differences here. And so with the data assimilation, with our system, we use updated initial conditions, and here we were able to create 4 deterministic forecasts. So 2 of them were initialized at 18Z on the 29th, and 2 were at 0Z the 30th. And just a little background, the conventional forecasts just assimilate conventional observations, while the infrared assimilate conventional observations, as well as the all sky infrared, all sky infrared. Okay, so just kind of working our way back down the same path. If you take a look here at the improved mesh track, essentially most of the forecasts, I should say, really followed that National Hurricane Center observation, specifically between 0Z and 18Z on the 31st. Again, the most essential day that we need to be able to prepare and keep communities up to date on what was happening. So you can see, especially toward the end, pretty much the last 4 open circles, which are every 6 hours. So pretty much they nailed kind of where that landfall was going to be. So that was really good. And then again, taking a look at the intensity. So here we can see just the minimum pressure by each forecast. And then this shows the absolute error. And essentially both of the forecasts did a pretty good job of capturing when that steep drop in the minimum sea level pressure was going to be. The timing, of course, was really essential. And also, they kind of quantified how low that pressure was going to get, much more than the work model did on its own. And then when looking at the maximum wind, we saw a similar pattern. The forecast did better with, again, capturing that steep uprise in the forecast, but the infrared forecast specifically initialized at 0Z the 30th performed best, where it remains within about a 25 knot range of what was observed by the work model. And then, so this is our biggest focus of this project and our biggest finding here. Again, the brightness temperature. So again, this is all comparing the same time here. This is the conventional brightness temperature analysis, the infrared, and you can see these 2 models did a much better job of capturing that the high cloud tops, and specifically the infrared brightness temperature really captured the eye wall and the overall magnitude of the structure. Pretty much in these graphs, Cape Bird is below this storm at the moment, so you can see how intense that was, even though it was only a Category 1 hurricane. And so those satellite observations really played a vital role in being able to improve the forecast and kind of model that hurricane better. So in conclusion, we say without data assimilation, the work model essentially underestimated the storm and what was expected to happen. But data assimilation helped improve the initial conditions, which then improved the forecast of the storm. Just to add a bit more, the importance of this for different coastal communities, of course, comes to like emergency management and preparing these communities for what is to come. Specifically, this hurricane, as I mentioned, was the first in 120 years. So it was really vital that we perform, a good forecast. And this in the future can help us better understand if another hurricane comes by Cape Bird, just kind of how we can prepare, how we can utilize different resources in order to, better forecast and prepare these communities. And I forgot to mention at the beginning, but there were a few fatalities associated with this because of the lack of preparation. So it was about 9 people that went missing because they were fishing and things like that. So it was important that we kind of got that, improve that forecast in order to avoid those fatalities. So here are all my resources. And then I would like to acknowledge both of my PIs, Dr. Zhang and Dr. Chen, as well as the Penn State Advanced Data Assimilation, Penn State Center for Advanced Data Assimilation and Predictability Techniques. And I also like to acknowledge NOAA's Cooperative Science Center in Atmospheric Science and Methodology. I forgot to also mention I'm an NCAS fellow, so also like to acknowledge them as well. So I would love to answer any questions if you all have any.
Hi, Alisha. Marie DiLorenzo, Penn State alum. So as you went through this, are there other pieces of information that you wish you would have had to help you build that better model?
I would say, that's a good question.
So I think, again, Cape Verde is a data void region, and so that kind of made it hard to kind of analyze the first forecast because there was just the work model was the only one to go kind of based off of. So I think it would have been interesting to kind of have another forecast to compare the National Hurricane Center's official observations with and see if that also performs like poorly or it did any better. But again, that's kind of where like data assimilation comes in because it allows to kind of counteract with that data void region, you know, not having, you know, radars or buoys and things like that. So that helped out with that. Thanks.
All right, thank you.
Thank you.